All right, let's talk about deep learning. It is, without a doubt, the engine behind so much of the technology we use every single day. But what's really fascinating is how it went from this kind of forgotten academic idea to a world-changing force. It's an incredible story of failure, persistence, and then this sudden explosive breakthrough. I mean, think about it. If you've ever unlocked your phone with just a glance, or asked a smart speaker for the weather, or even used a translation app, you've used deep learning. It's this invisible intelligence that makes all of these things feel, well, almost like magic. But what is it really? Okay, so at its core, deep learning is all about teaching computers to learn from examples, kind of like how we humans do. It uses what are called artificial neural networks, and the deep part just means they have lots and lots of layers to process information. Now, it's inspired by the brain, for sure, but it's not trying to perfectly copy it. It's more about using that layered structure to make sense of incredibly complex data. So how on earth does a machine actually learn? Well, the secret is all in those layers. It's this fascinating process of building a really complex understanding from the simplest possible pieces, one step at a time. Let's take something like teaching an AI to recognize a face. It's a great example. You see, the network starts with just the raw image, right? Just a grid of pixels. The first layer doesn't see a face at all. It just sees basic things like edges, lines, and curves. Then the next layer takes those simple shapes and starts combining them into more complex features, maybe something that looks like an eye or a nose or a mouth. And finally, a higher layer puts all those features together and concludes, hey, that's a face. Each layer is building a more abstract idea on top of the last one. It's like building with Lego. And that right there is the fundamental shift. It's the real game changer in how we build AI. See, in the old days, a programmer would have to sit down and manually write code to define every single feature. They'd have to say, this is what an eye looks like. This is what a nose looks like. It was all handcrafted and super brittle. But with deep learning, the model figures out the most important features all on its own, just by chewing through thousands or even millions of examples. It learns what to look for, which is just a monumentally more powerful and scalable way to do things. But here's the thing, this was absolutely not an overnight success story, not even close. For decades, the ideas behind deep learning were basically just gathering dust, stuck in this period that researchers call the AI winter. And the core problem was pretty simple, really. The theory was there, but the technology just wasn't. Training these deep, multi-layered networks required a ridiculous amount of computing power and just mountains of data, things that were basically science fiction at the time. So researchers went for simpler, more manageable methods, and deep learning was pretty much seen as a dead end. And if you look at the history, you can really see just how long this road was. I mean, you had these early sparks of innovation way back in the 60s, and then Lynette had some real success reading zip codes in '89. But then, progress just hit a wall for decades. That was the long AI winter. The real game changer, the moment everything shifted, was in 2012. A model called AlexNet, running on modern GPUs, just completely destroyed the competition in a major image recognition challenge. That one event basically signaled the winter was over and kicked off the deep learning big bang we're living in now. So what happened in the years since that 2012 revolution? Well, deep learning didn't just stay in the research lab. It broke out in a huge way and has basically reshaped nearly every industry and, huge parts of our digital lives. And the applications just exploded into every corner of our world. It's in the consumer tech we use every day, right? Our voice assistants, the recommendation engines on streaming sites. But it's also quietly working behind the scenes in some really critical industries, detecting financial fraud, generating incredible art and music, and even revolutionizing scientific research in fields like drug discovery and material science. It's everywhere. And the impact of this shift was just immediate and massive. To put a number on it, in 2015, Google's speech recognition accuracy jumped by an incredible 49%. A leap like that would have been completely unthinkable with the older methods. And this power scaled globally. It helped Google Translate support over 100 languages, breaking down communication barriers by understanding the meaning of whole sentences, not just translating word for word. And it's even changing the physical world around us. An AI system recently helped scientists discover over 2.2 million new stable materials. I mean, that's a feat that could dramatically accelerate everything from better batteries to next-generation electronics. Just mind-blowing stuff. So yeah, it's really easy to be amazed by all these achievements. But it's also absolutely critical that we understand the limitations and the challenges that come along with such a powerful technology. It's not perfect. For all their power, these models can be surprisingly fragile. Take this idea of an adversarial attack. Someone can make these tiny, almost invisible changes to an image, changes a human would never even notice. But to the AI, that image suddenly looks like something completely different, and it makes a confidently wrong decision. This shows a really fundamental vulnerability in how these systems actually see the world. And this points to the famous black box problem. We know these systems work, we see the results, but we often don't fully understand why they arrive at a specific conclusion. They can learn these incredibly complex patterns, but their decision-making process can be totally opaque. And that's a huge challenge for things like accountability and trust, especially in high-stakes fields like medicine or finance. Which, of course, brings us to the final question. We have successfully built machines that can learn from data at a truly superhuman scale. That's an incredible achievement. But maybe the next great challenge isn't just about making them more powerful, but about making them more robust, more transparent, and more understandable. We've taught them to learn. So what's the next lesson we need to teach them to make sure this revolution truly benefits all of us?